All right, so we've spoken about inverse functions before, and so clearly the key thing there is to swap our x and y values, isn't it? Interchange x and y and then make y the subject. So in our log laws, this here is the most significant rule there. So if a to the x is equal to y, if I want to get that into log form, there's the base, log base a of y is equal to x. So notice in this form here I've got y equals, in this form here I've got x equals. So that's how we get the inverse for our exponential and log functions. So in actual fact, my e to the x and log e to the x are in fact inverse functions. All right. So if we need to calculate without technology, say the domain and range of the inverse. X equals 3e to the y plus 1. Transpose everything. Once we get to there, there's my base, log base e of all of that expression. X minus 1 on 3 is equal to y. Yeah? And therefore the inverse, so we'll have to write it as y inverse, is equal to natural log of x minus 1 on 3. So the next part of it is, say, the domain and range of the inverse. So if we consider the original function, the domain of e to the x is simply r. The range of e to the x, so the range of that, it's that graph shifted up one, isn't it? So that horizontal asymptote has moved up there to y equal 1. So that range is from 1 to infinity. So how does that compare? So we know the domain and range swap over. The domain of f inverse is equal to the range, which is 1 to infinity, which fits in. If x is smaller than 1, that becomes negative, which can't happen. And the range of f inverse is equal to the domain, which is r. All right. We're going to use technology to do that. The easiest way to start is just rewrite our equation as x equals 3y plus 1, which is what we've got up here. Okay, so then if we do that, if we solve now that equation for y, it'll rearrange everything for us and give us y equals. Now often with our logs, it'll even give us the domain straight away. If we want to use our technology to find our domain, just use the domain function. So domain of the natural log of x minus 3 with respect to x is from 1 to infinity. So there's a big tick up there. And there's no range function, but if I get the domain of the original function there, okay, so don't forget that is the range of my inverse function. So I get from negative infinity to infinity, which is r. All right, so you can use your technology there to get your inverse and also get your domains. If we continue on, sort this out. All right, calculate the inverse at the domain and range without technology. Righto, so first steps first. What are we going to write? We'll write x equals 2 log base 10 of y minus 1 plus 1. So rearrange everything, take 1 across, divide by 2, log base 10 of y minus 1. So now, there's my base. So that implies then that 10 to the power of x minus 1 on 2 is equal to y plus 1. So y is equal to 10 to the x minus 1 on 2 minus 1. So f of x, so I've got f inverse of x is equal to 10 to the x minus 1 on 2, minus 1. So don't forget, we've also got to state the domain and range of the inverse. So So the domain of the inverse is the range of the original. Range of the inverse is the domain of the original. So what do I know about this graph here? Well, the domain of that is for x is greater than 1, all right, because I can't have natural log of a negative number, or log base 10. So that domain, so this range here becomes from 1 to infinity. My log function, which just looks like that. So the range of that is R, so the domain of that is R. Does that seem reasonable? Well, yeah, because I can put any x value I want in there. So there's my domain and range of that function there. Okay, so if I'm going to use my CAS calculator, I'll define, this time I've decided to define the function. I've called it f1 of x so that if I want to graph it, it graphs straight away in my calculator, so that's it there. Same sort of thing though, I want to swap the x and y values, so that's how I can swap the x and y if I use the function notation. Solve that for y, there's my inverse function. Now it looks a little bit different, but if you think about that top line, that's just the same as 10 times a half of x plus 1, which is 10 x plus 1 on 2, which is the same as our, our inverse function, which has got a mistake in it, hasn't it? Look at that. Good thing we did it both ways, so I've got to take that across to a plus 1. That's a nuisance. Yeah, so continuing on, if we get the domain of f1 of x, which is that function there, which is from 1 to infinity, so that's the range of my inverse, which is up there. And then if I put in the domain of my inverse function over here, that's really what the range is, isn't it? That's the range of the inverse function. Well, actually, it's the domain of my inverse function. What am I talking about? So the domain of my inverse function is from negative infinity to infinity, which is R, which is there. So hopefully you just get used to using your technology to find your domain and ranges.